All right, welcome to the Explainer. We've all sat through those long OPE revision sessions, right? So today, we're cutting right to the chase. We're taking hours of that material and crunching it down into one powerful 5-minute strategy to help you absolutely crush your exam.
So you're getting ready for the Python OPL, and it can feel, well, pretty overwhelming. But here's the thing. What if I told you that most of those problems aren't these crazy, unique puzzles? They're really just the same few ideas dressed up in different clothes. The big secret, the thing the instructors keep coming back to, is just learning to see the patterns.
Okay, so here's our game plan. We're going to cover the OOPE challenge, those essential coding patterns, how to solve common problems, some tips on smart habits for clean code, and finally, we'll pull it all together into your winning strategy. Let's do this.
All right, Section 1, the OPE challenge. And really, it's all about patterns. I mean, if there's one thing to take away from all the revision sessions, it is this. The OPE is not a test of memorizing a million different things. It's a test of pattern recognition. The instructors aren't just chucking random problems your way. They want to see if you can spot the hidden structure in the code.
And this quote right here, it really nails the whole philosophy. We don't say, this follows these patterns. This is how you break down the problem. This is how you think clearly. You see? It's not about them just handing you the answers. It's about teaching you how to think your way to the answer. The goal isn't for you to memorize one specific solution. It's to build a way of thinking that you can use on any problem they throw at you.
So, what are these patterns they keep talking about? Well, let's get into it. Section 2, Essential Coding Patterns. These are the building blocks. And when it comes to data processing questions, and trust me, that's a huge part of the exam, pretty much everything boils down to 3 core ideas. If you can get these 3 down, you are in really good shape. First up, we've got mapping. Think of this as your assembly line. You've got a bunch of items coming in, and you need to do the exact same thing to every single one. So, for example, you have a list of number strings like 1, 2, 3, and you want to turn them into actual integers. That's mapping.
Next up is filtering. This one's all about being picky. You've got a big collection of stuff, but you only want the items that match a certain rule. This sieve analogy is perfect here. You pour everything in, and only the things you want, say just the even numbers, actually make it through to the other side.
And the third one is aggregation. This is where you take a whole pile of data and just smush it down into one single value. You know, whenever a question asks you, how many are there, or what's the total sum, or find the biggest one, yep, that's aggregation. You're reducing it all down to one answer.
Now, here's where it gets really cool and where you can show you know your stuff. A lot of people might write 3 different for loops to do this. One to map, one to filter, one to aggregate. But the instructors point out a much better way. You can actually combine all 3 of those things into a single, slick list comprehension. It's way cleaner, it's faster, and honestly, it just shows you really get it.
Okay, so theory is one thing, but let's actually see how this stuff works in practice. Section 3, Solving Common Problems. We're going to look at a couple of classic problems that you're very likely to see on the OPPE.
First up, a real logic puzzle favorite, counting hostile pairs. So, what's a hostile pair? Imagine you get a list of numbers. You need to figure out how many pairs of those numbers have 0 digits in common. None at all.
Okay, when you see a problem like this, the first rule is don't panic and try to solve it all in one go. You have to break it down. Step 1. Just focus on generating every single possible pair of numbers from the list. Step 2. Write a totally separate, small function that does one simple job. It takes 2 numbers and tells you, yes, they're hostile, or no, they're not. And then step 3, you just loop through all your pairs, use your little helper function, and count up the yeses. See? That's that input, process, output mindset we're talking about.
And this is such a great point from the instructors. Programming is about if you know something already exists and you reuse the pattern. Seriously, don't reinvent the wheel. For that first step, generating pairs, Python has a tool for that. The instructors point to the combinations function in the itertools library. Using it is a massive shortcut and shows you know your way around the standard library. It's all about using the right tool for the job.
All right, let's look at another classic, finding anagrams. Now, be careful with the definition here. Trigger and triggered are not anagrams. They have to have the exact same letters and the exact same count of each letter, like listen and silent.
So how do you solve this? Well, there's a really clever trick.
Instead of trying to compare the words directly, which is messy, you transform them first. You take each word and you just sort its letters alphabetically. Think about it. If you sort listen, you get EILNST. If you sort silent, you get the exact same thing. Now the comparison is super easy. If the sorted versions match, they're anagrams. It's such an elegant and efficient solution.
Okay, so you've got the logic down, but that's only half the battle, right? When you're under pressure in a timed exam, it's the simple little mistakes that can totally trip you up. So let's talk about that. Section 4, smart habits, clean code, and how to avoid those simple mistakes.
This is probably the #1 mistake people make, and the instructors see it all the time. Bad variable names. And I mean one specific bad habit. Do not name your variable list, or string, or dict. Don't use the names of built-in Python things. Call it nums, call it mylist, call it whatever you want, just not list.
So why is this such a big deal? Well, when you say list equals 1, 2, 3, you are basically wiping out Python's own list function and replacing it with your variable. So later, when you try to do something like list my_tuple, Python doesn't see the function anymore. It sees your variable, and it throws this super confusing error, type error, list object is not callable. It's such a tiny mistake, but it'll bring your whole program to a screeching halt.
Look, your code is going to break. It just is. So what do you do when that happens? Every single instructor agrees on this. The print command is your best friend. It is your lifeline in that exam. Don't just stare at the code and guess what's happening. Stick a print statement in there. See what your variables actually are. Print the list before the loop, print it after the loop. Make the invisible stuff visible. I promise you, it is the fastest way to find what's wrong.
All right, we've got the patterns, we've got the good habits. Now let's put it all together. Section 5, your winning strategy. This is the master plan for exam day.
Now listen up, because this is a huge piece of strategic advice from one of the instructors. See that number, 40? That's how many marks you can get just from the data processing questions alone. You know, the ones that use mapping, filtering, and aggregation. 40 marks is enough to pass the entire exam. So if you're wondering where to focus your energy, start there.
Okay, on exam day, you need to remember these things. First, you're in charge. You don't have to do the problems in order. Jump around, find one that looks easy and tackle it first to get some confidence and momentum going. And for every single problem, take a breath and break it down into those 3 parts. Input, process, output. What am I reading in? What am I doing to it? What do I print at the end? That simple structure will keep you grounded and stop you from getting overwhelmed.
So at the end of the day, what we've talked about isn't just a bunch of random solutions. It's a whole method. It's a way of thinking. You've got the patterns to see through the problem, the habits to write code that works, and a real strategy for the exam itself. So you have the plan. The only question is, which problem are you going to solve first? You've got this. Good luck.